All right, welcome back to calculus. So we are now going to be going through surface areas of revolution. This will be problem 3a. Find the surface area of revolution by rotating square root of 5 minus x between 3 and 5. So we're going to say f of x equals the square root of 5 minus x. And we want this between x equals 3 and 5. So the first thing to do is to think about what is the formula we're going to use for surface area. So if I go ahead and give myself a little drawing of this thing, okay, we're going to be dealing with 5 and 3. So I want this arc length rotated around the x-axis here. Okay, just double checking. Rotate around the x-axis. Okay, so what we're going to do is we're going to multiply the radius. That's going to be f of x. So we're going to have f of x times ds, and we're going to go ahead and rotate this. It's going to be a 2 pi r times the surface times the arc length. We're going to go from 3 to 5. Okay. So some things we have to deal with is figure out what the heck is ds. ds, again, from the last couple is 1 plus f prime x squared. Okay, we have to sort that out. So we're going to have f of x equals, I'm going to write it in calculus, so that's going to be 5 minus x to the 1/2 power. F prime of x is equal to 1/2, 5 minus x to the negative 1/2 times the chain, which is negative 1. Right? And now what we're going to do is we are going to square this thing. So the chain of negative 1 isn't really going to matter too much, but it's going to be 1/4 times, if I square this thing, it's just going to be 5 minus x on the denominator, right? And the negative 1 squared is just going to be 1. And now what we have to do is we have to add this to 1. Okay, and you have a couple of different options to go with this one. Generally, it's good to find the common denominators of this thing and go ahead and figure that out. So we're going to say we have 1/4 by negative 5 minus x plus 4 5 minus x over 4 5 minus x. Okay, so let's go ahead and figure this out. That's going to be, I'm going to put it all over 1. We have 4 5 minus x here. And then we're going to say 1 plus, this is going to be 20, right, minus 4x. So we're going to end up with 21 minus 4x divided by 4 5 minus x. Don't multiply out denominators, it's not worth it. All of this is under a square root here. Okay, but don't forget that with the way we set this up, there was a 2 pi f of x at the beginning. So we have a 2 pi integral f of x, which is the square root of 5 minus x. Okay, and now I'm going to go ahead and apply the square root here. We have square root of 21 minus 4x divided by 4. Let's see if we can get this to come out better. Okay, we have the square root of 5 minus x. Taking the square root of this 4 here, we're going to end up with a 1/2. Right? And again, we're going from 3 to 5. Right? Some stuff cancels. That's the whole point. Okay, that's why you don't want to multiply this out until you really have to, because we're always hoping for the idea that there's some stuff that's going to cancel some more. So we end up with pi integral of the square root of 21 minus 4x. And what are we going from? We're going from 3 to 5. So I'm going to go ahead and say let u. So now it's a Calc 1 problem, right? Let u equals 21 minus 4x. When u is equal to, when x equals 3, u is equal to 21 minus 4 times 3 is 12. So we end up with a 9. And we have when x equals 5, we have 21 minus 20, which gives us 1. Okay, our du, so we go ahead and say our du is going to be negative 4dx. So I'm going to go over here and I'm going to say we have pi. We have, instead of 3 to 5, I'm going to say we have 9 to 1, right? When x was 3, u was equal to 9. When x was 5, u was equal to 1. Okay, so we are there. And then we have u to the 1/2, but don't let me forget my my du here, right? Because du is going to be 40x. So I have to multiply and divide by 4. So we're going to go ahead and multiply by a -4, 1/4 here. And here's what I'm going to do is I'm going to say this is going to be pi over 4, and we have 1 to 9 of u to the 1/2 power. I just go ahead and flip the side, the limits of integration, because I did that to get rid of that sign. Okay, so that's just going to be pi over 4. This is going to be u to the 3/2 times 2/3. There's more stuff that cancels, so we cancel here. So we end up with a pi over 6 times a u to the 3/2 power, going from 1 to 9. So yeah, that's not going to be too bad. So we just have pi over 6, 9 root 9, that's 3/2, minus 1 root 1, and root 9 is going to just be 3. So we're just going to have pi over 6. 9 times 3 is 27, minus 1. So we have pi over 6 times 26. 26 pi over 6. I guess we can cast out a 2 out of this and come up with 13 pi over 3. Hooray. And that should do it for your first surface area of a revolution. Okay, so I hope that helps a little bit. Good luck, everybody, and do well on the test.